Welcome to my Operations Management tutorial on Capacity Requirements Planning and Enterprise Resource Planning. My students can access the video tutorials for these problems using the Content menu in D2L. YouTube viewers can access the video tutorials on my MOOC on udemy.com. I have a long and short version of the URL posted on the screen, and I will post this URL in the description. On the screen, you see an overview of many of the topics in operations management. This diagram shows how they relate to one another. The forecast drives the aggregate planning process. The result of aggregate planning is the master production schedule. Key workstations are checked for adequate capacity using rough cut capacity planning. If there's not enough capacity, the aggregate plan is changed or the master production schedule is changed. The master production schedule drives the material requirements plan. That is checked using capacity requirements planning. If there's not enough capacity at any workstation, either the aggregate plan or the master production schedule has to be updated. The MRP plan drives shop floor scheduling and purchasing. Shop floor scheduling for what you make and purchasing for what you buy. Now let's look at some terms regarding capacity planning. Capacity requirements planning is the process of determining short-range capacity requirements at every single workstation in the factory. Load reports are department or work center reports that compare known and expected future capacity requirements with the projected capacity available. In other words, they tell you how well or how poorly each workstation is going to be able to handle the demands on it for the planning period. Time fences are a series of time intervals during which order changes are allowed or restricted. We'll talk about that in more detail later. We need capacity requirements planning because not all MRP plans are doable. That is, you may not have the capacity at certain work centers to complete the plan. So it's certainly possible that a plan might overload one or more work centers without overloading the entire factory. But if even one work center can't meet the plan, then the plan is not doable. So when you have overworked work centers, you have to redo the plan, or you have to adjust the capacity at that work center. It's also possible that a work center may not have enough work. We call that being underloaded. We may try to correct this, or we may simply use those workers somewhere else. We're going to talk about 8 possible capacity requirements planning corrections. 1. Eliminating unnecessary requirements. 2. Job rerouting. 3. Lot splitting. 4. Increasing capacity. 5. Subcontracting. 6. Increasing efficiency. 7. Pushing work back to a later time period. And 8. Revising the master schedule. In regards to eliminating unnecessary requirements, you may think, well, how can we have unnecessary requirements? Well, we could have lot sizing, making more than we need right now because it's more efficient. We could have safety stock, and we could be adjusting our inventory levels. Those are all things that could make sense, but if they're causing a work center to be overworked, then perhaps we should either cut back on it or wait until another period. Reducing or eliminating lot sizing, safety stock, inventory levels, and other unnecessary requirements can lower our capacity requirements right now when we don't have enough. MRP assumes that each job is routed through the optimum sequence of work centers for that job. For example, a job with a lot of drilling would go through the high-speed drill press. Sometimes other routings might work. For example, sending the product that needs a lot of drilling through the low-speed drill press. It's less than optimal, but it might be a way of getting the extra capacity you need by taking part of the overworked high-speed drill press and giving some of its work to the underworked low-speed drill press. The job rerouting we just talked about sends all the work to the alternative work center. All of the job is sent to the low-speed drill press instead of the high-speed drill press. So if the high-speed drill press has some capacity, but not enough, we might send all the jobs that it has the capacity to work to the high-speed drill press and then send the rest to the low-speed drill press. This is called lot splitting because we take the lot and split it into 2 pieces. Part is done on the high-speed drill press, for example. Part is done on the low-speed drill press. After that work center, the job would be put back together into one lot. We can also try increasing the capacity of the work center. For example, overtime, adding a shift, working weekends, or even subcontracting, which I'll talk more about in a moment. The real issue in terms of deciding whether or not to increase capacity is it needed for long-term or short-term? Short-term, overtime might make sense. Long-term, it might be too expensive. Subcontracting is having someone else do the work for you. In other words, outsourcing. This can be done long-term or short-term. And here we're talking about not outsourcing the entire production process, but the work center that you have not enough capacity for. Of course, this option assumes that you can find a firm with the available expertise and equipment to do whatever it is that you don't have the capacity to do. It also assumes that they will have excess capacity. and it also assumes that there's no technological secrets that you're worried about them stealing. If there are inefficiencies in the work center, correcting them raises capacity. Efficiency is just output over inputs. If we can get more outputs for the same inputs, we raise our capacity. Of course, I would argue that if the work center is being inefficient, you should correct that regardless of whether it has enough capacity or not. Once you correct the inefficiency, that generates extra time. That can be used somewhere else, cross-training, making another product, or something else useful. As I mentioned before, lot sizing, safety stock, and changing inventory levels can cause you to produce more than you need right now. If that causes work centers to be overloaded, then it might make sense to push that production back to a later period or forward to a future period. This shifting makes especially good sense when you have lumpy demand. So what you're doing in that case is shifting the extra demand from lot sizing, safety stock, and inventory levels from a period of high demand to a period of low demand. Shifting works forwards or backwards in time has implications for the MRP plan. Using the bill of materials shown on the screen, let's assume that we want to shift the two Bs. If we shift it back, in other words, we make it earlier, that doesn't affect when we make the A or the C. But in order to make the Bs, the D's and E's have to be finished. So making B earlier means we have to make D and E earlier. On the other hand, if we want to make B later, that doesn't affect D or E. They can be made in their original schedule and just held in inventory until we're ready to make the B. Doesn't affect the C either because there's no connection between B and C. But if we're going to make B later, then that causes us to have to make A later. So making things earlier affects the stuff below it in the bill of material. Making stuff later affects the stuff above it in the bill of material. Now let's talk about revising the master schedule. All capacity needs for every work center flows out of the master production schedule. If it changes, then the load on every work center changes. Some of the work being scheduled in the master schedule might be due to increases in inventory or lot sizing or safety stock. Delaying those changes in the master production schedule can free up some capacity now. And since the master production schedule drives off of the aggregate plan, what we're really talking about is not making changes to our independent demand item. As I stated earlier, these types of changes are especially useful when demand is lumpy. Now let's talk about enterprise resource planning. In his book, Business at the Speed of Light, Bill Gates refers to ERP in part as a digital nervous system. The ERP computerizes the business logic of the company. So for example, your nervous system, if you put your hand on the hot stove, your nervous system tells you to move your hand. A business digital nervous system, an ERP system, says if inventory drops down to this level, order some more. Cause and effect, problem and response. With a good ERP system, data is entered into the computer system once and is available throughout the company to anybody that needs it, just the data they need. Making all of this data available to anyone who needs it, when they need it, and only entering it once has the potential to improve all aspects of the company's operations. This is where you get the savings from MRP and the efficiencies from MRP. As an example of that, let's talk about ERP at Dell computers. And specifically, we're talking about their desktop computers because they outsource the production of their laptop computers. When you go to order a computer from Dell, you log into their website, you select all your components, you enter your shipping address, you enter your credit card information. In other words, Dell outsources the data entry to you. Once you hit buy, they suck the money out of your credit card because they're not going to make the computer for you if you can't afford it. They then use the components that you ordered for your computer to place an electronic order with their supplier so that they have the parts they need to make your computer. Once the parts arrive from their vendor, they schedule your production electronically. Your order and parts information also automatically flows into the accounting system so they can account for the profits they made from your order. All of this is done electronically. Nobody has to move files around. Nobody has to move data around. If you enjoyed this video, please click like and consider subscribing to this channel.